Welcome to this deep dive into the OpenBCA input templates. OpenBCA uses two Excel workbooks, a configuration file, and a program input file. In this first video, I'll focus on the configuration file. This establishes the system-level assumptions for the analysis and defines how each benefit or cost referred to in the OpenBCA as a value stream will be calculated. In the second video, we'll move to the program input file and walk through the programs, measures, savings, costs, and load shapes being evaluated. Now, opening up the configuration file, before entering any data, let's briefly take a look at the front page. This tab provides links to supporting resources like the National Standard Practice Manual, as well as the MTR Handbook, and links to the OpenBCA webpage. This will provide additional guidance on benefit cost analysis, principles, impact categories, and how to develop your own jurisdictional specific test or a JST. They're intended to provide context and guidance while the user remains responsible for selecting their own assumptions and inputs appropriate for their analysis. Moving on to the Common Data tab, this is where we enter information related to global assumptions that are applied across the entire analysis. These include items such as dollar-year, program year, discount rates, inflation rates, electric and natural gas line losses, and the framework used to treat costs and transfer payments. Both input files also include support buttons, shown to your left here with these macro buttons. These serve as data dictionaries for these input templates and provide definitions and input guidance for the fields used throughout the workbook, making them a useful reference when you need clarification on a parameter, unit, or expected data format. Because these assumptions are used throughout the model, they should be internally consistent and aligned with the JST being evaluated. The tab also allows us to define subsets. Subsets can represent different geographic regions, customer segments, avoided cost cases, or even sensitivity scenarios. There is also an option for users to enter their information in custom periods. You can define your custom periods if your data does not support a standardized time series format, for example, super peak, off peak, or just regular peak, and define those custom periods in this format and enter your inputs in that way. Now, moving on to the configuration data tab, this is where we define the structure of the analysis and select the value streams included in the JST. OpenBCA supports value streams across several broad categories, including electric utility system impacts, natural gas utility system impacts, host customer impacts, societal impacts, and other fuel. And we also have the option of 5 custom value streams, which can be configured to your own jurisdiction in case any of the above value streams are not sufficient for your analysis. For each value stream, we specify the name, the impact category, and a suggested unit for labeling, as well as if it is included and if subsets apply to it, as well as the data granularity or calculation type. The calculation type determines how OpenBA combines the value stream data with program and measure inputs. Depending on the value stream, the input may be hourly, monthly, annual, a custom period one, or even just a percentage adder. The most important point is that these value streams and units work together, and the selected calculation type, commodity, units, and data granularity must all correspond to the data that will be entered later. Now, the configuration file works through 3 macros. They are listed on the right here under step 3. The first one is the build value stream button, which creates the required input tab for each value stream using the calculation type or data granularity selected in the setup table. The input avoided cost data button takes you to the first generated value stream to enter data, and the build program input file opens up the program input file and generates the required electric and natural gas load shape structure based on the most granular time series calculation selected here for each fuel type. The Clear All Sheets button removes all previously generated value streams in case you would like to start over from scratch. Now, looking at these macros actually work. If I hit the Clear All Sheets button, all of the tabs to the right of the configuration data have been removed. Clicking the Build Value Stream button, you'll see that all of the value streams in this table now have their own dedicated sheet. And moving on to the first value stream, in this case, energy generation electric. We see time series hourly format with a table as well as the entered unit, dollar value, as well as the calculation type. Depending on the configuration, this may be an avoided cost, an emission value, a capacity value, or any value used to monetize a DER impact. Before entering data here, confirm that the units, dollar basis, and any subsets are correct. And it is important to note that renaming these worksheets after they are generated or altering their structure might cause errors since the application expects the workbook to retain the template's established format. Now, moving back to the configuration tab, before moving to the program input file, check that all of the global parameters are complete, that all of the selected value streams reflect the intended JST, and the required input templates or input tabs have been generated and populated correctly. Also confirm all units and time resolutions. In particular, the load shapes in the program input file will need to support the highest time series granularity selected for the corresponding electric or natural gas value streams. Now, hitting the program input file will open up the program input file and give you a pop-up on if you would like to overwrite any existing electric load shape data and natural gas load shape data. Hitting yes would give you blank tabs with the correct and the most granular time series applicable for that certain fuel type. In the next video, we'll walk through the program input file and show how measures, program savings, costs, and load shapes connect back to this configuration.